Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic reactions of alcohol. For links to other topics and question timestamps, please visit video description. Question 27. How many moles of hydrogen are evolved when an excess of sodium metal is added to 1 mole of citric acid? This is citric acid. We have carboxylic acid functional group. We have alcohol functional group. Again, carboxylic acid and carboxylic acid functional groups are present. Now, sodium metal can react with both carboxylic acid and alcohol group. So the product will be like this. COONA, sodium salt of carboxylic acid, CH2, COONA, then we have O negative, Na positive, CH2, COONA. Now we can see 1 hydrogen, 2, 3, 4 hydrogen atoms are removed, or we can say 2 hydrogen molecules are removed. So therefore answer is 2 moles of hydrogen molecules. Question 39. Which reactions have a colored organic product? First one is ethanol, which is aldehyde plus 2,4-dinitrophenylhydrazine reagent, which is known as 2,4-DNPH. Now 2,4-DNPH can give positive result both with aldehyde and ketone, and it forms orange precipitate as product. As ethanol is aldehyde, so therefore this will give colorful product. Second one is ethanol. Ethanol is alcohol. Acidified potassium dichromate converts ethanol into ethanol, which is aldehyde, and this is colorless product. In third one, we have alkene, which is reacted with cold dilute acidified potassium manganate. This one will convert alkene into diol. Again, this product is not colored, it is a colorless product, so therefore 3 is also incorrect. As only option 1 is correct, answer is therefore D. Question 27. Which reaction will form a strong organic base? Part A, ethanol and acidified sodium dichromate. Now acidified sodium dichromate is oxidizing agent. And it can convert ethanol into aldehyde. As no base is formed, so therefore this is wrong. Then we have ethanol and hot aluminum oxide. This causes elimination reaction and water is removed from ethanol and alkene is formed. Hydrogen will be removed from adjacent carbon. This will form double bond along with the removal of H2O. Again, no base is formed, so therefore this is also wrong. Part C is ethanol and sodium. Sodium is a metal. It can react with alcohol to form alkoxide along with hydrogen gas. The product form will be O negative, Na positive. This is sodium ethoxide. along with hydrogen gas. Now this product is basic ionic compound. Where ethoxide is a strong base, so therefore part C could be correct. And the last one we have ethanol and hydrogen chloride. This can form chloroethane along with water. No base is produced, so therefore this is incorrect. The only one that produces strong base is part C. Question number 26. An excess of dry HBr is warmed with compound Y. What is the major product of this reaction? Now let's see what does dry HBr do. First reaction is that it can replace OH of primary alcohol. HBr can also be added to alkene. Now the addition to alkene should be according to Markovnikov rule. Markovnikov rule says that hydrogen of HBr goes to the carbon atom having more number of hydrogen atoms. So let's see how many hydrogen atoms are present on each carbon atom. This has no hydrogen atom because all 4 bonds are made. This one has 1 hydrogen atom. This carbon does not have any hydrogen atoms. This has 2 hydrogen atoms. And this is OH of primary alcohol. So HBr will replace this OH with Br, and according to Markovnikov addition we should have Br over here and H on this carbon. Similarly, according to Markovnikov addition, Br must be here and hydrogen on this carbon atom. Let's see which answer is correct. We have OH unchanged, so this is not the answer. We have OH unchanged, no. This one is replaced by bromine, so yes, this is good. This bromine is attached to this carbon atom, it is also correct. This bromine is attached to this carbon atoms, it is also correct. So the answer should be part C. In part D we can see this one is correct, while the position of bromine should not be here. It should be on the other carbon atom according to Markovnikov rule. So therefore this is wrong. Question number 29. What is the skeletal formula of the compound formed when this compound is heated under reflux with potassium dichromate in the presence of acid? So let's see what have they given to us. CH3, C double bond, C, CH2, OH. So we have primary alcohol and we also have a double bond, alkene. Now potassium dichromate is oxidizing agent. It oxidizes primary alcohol to aldehyde and aldehyde further to carboxylic acid. While alkene is not affected by potassium dichromate, so only this portion must be converted into carboxylic acid. Let's see which part is correct. So in part A they have converted into aldehyde, which is wrong because it won't stop at aldehyde, it will convert into carboxylic acid. Part B, they have converted into carboxylic acid and alkene is unaffected, so it means it is the correct option. In part C, they have changed the alkene, which is not possible. In part D, they also have changed the alkene, which is not possible. So the only possible answer is part B. Question 38. When the apparatus is set up as shown, an orange precipitate forms in test tube Z. So we have two different test tubes. In first test tube we have acidified potassium dichromate, which is a powerful oxidizing agent. In second test tube we have 2,4-dinitrophenylhydrazine or 2,4-DNPH. And we know that 2,4-DNPH actually it gives positive result with carbonyl carbon of aldehyde and of ketone. What could compound Q be? Number 1, this is an alcohol. We can see that this carbon is only attached to one other carbon atom, so it is primary alcohol. Now when passed through test tube Y, primary alcohol converts into aldehyde, and then when passed through the second test tube it gives positive result with 2,4-DNPH because of the presence of carbonyl carbon. Second one is also alcohol, but in this one OH is attached to the second carbon atom, so this is secondary alcohol. Now secondary alcohol oxidizes in the presence of potassium dichromate to form ketone, and ketone also gives positive result with 2,4-DNPH. Third one is alcohol in which carbon is attached to 3 carbon atoms directly, so this one is tertiary alcohol. The oxidation of tertiary alcohol is not possible, so therefore it won't give positive result with 2,4-DNPH. So only two options are there, 1 and 2, so therefore the answer is B. Question 25. Which product is formed when 3-methylpentane 1,3,4-triol is heated under reflux with an excess of acidified potassium dichromate 6? Let's first draw the structure of this compound. We have pentane, so it means we have 5 carbons with single bonds. We can number them 1, 2, 3, 4, 5. I'm not drawing hydrogen for the sake of easiness. Now on third carbon atom we have methyl, so it is CH3. On first, third and fourth carbon we have triol. Tri means 3 and ol is from alcohol, so there are 3 OH groups. One is on first carbon, second is on third carbon, and third is on fourth carbon. Now we have 3 types of alcohol. The first one is primary alcohol, as this OH is attached to this carbon, which is further attached with one carbon atom. So this is primary alcohol. Second alcohol is the one in which OH is attached with this carbon and this carbon is further attached with 3 other carbon atoms directly. So this is tertiary alcohol. The third alcohol is attached with this carbon, which is directly attached with 2 other carbon atoms, so it is secondary alcohol group. Now in the presence of excess acidified potassium dichromate, oxidation will occur and primary alcohol goes into aldehyde first and then moves towards the carboxylic acid. Tertiary alcohol is not oxidized. Secondary alcohol goes to ketone. So let's draw the possible product that is formed after oxidation. We have 5 carbon atoms. The first carbon is oxidized to carboxylic acid, so it will become COOH. The third carbon atom will remain as it is, so it would have one OH group and one CH3 group. While the fourth carbon atom will convert into ketone, so it will have double bond O. Now let's draw the missing hydrogen atoms. We have 2 hydrogen with this carbon, no hydrogen with this one, no hydrogen with this one, and 3 hydrogen with the corner carbon atom. Let's write the formula of this product as given in part A, B, C and D. So we have HOOC, then we have CH2, then we have carbon atom. As OH and CH3 both are attached with this carbon atom, so we'll write them in brackets. One will be CH3, the other will be OH. Then we have carbonyl carbon, and then in the last we have CH3. So we can match this product with A, B, C and D. And in A we can see we have COOH, then CH2, then carbon atom with 2 substituents, carbonyl carbon and CH3. So therefore A is the possible answer. Question number 24. Propane 1-ol can be reacted with acidified potassium dichromate 6 to form propanoic acid, reaction 1, or propanol, reaction 2. These are the chemical reactions. How can the reaction be carried out to ensure that reaction 2 occurs rather than reaction 1? We can see that the center one is alcohol as it has OH group attached. In reaction 2, aldehyde is being formed from alcohol. This is aldehyde functional group. In reaction 1, we can see that alcohol is being converted into carboxylic acid functional group. Now generally we know that primary alcohol, when oxidized, upon oxidation it forms aldehyde, and if further oxidation takes place, then carboxylic acid is formed. Let's move towards the options. A. An excess of acidified potassium dichromate 6 is used. As it is an oxidizing agent, so it will oxidize alcohol to aldehyde and aldehyde to carboxylic acid. In the question it says that how can we ensure that only reaction 2 occurs rather than reaction 1? So we have to stop the oxidation at aldehyde and further oxidation should not occur. In B, we can see an excess of concentrated sulfuric acid is added. Again, concentrated sulfuric acid is also a powerful oxidizing agent. So both these will result in the oxidation of alcohol to aldehyde and aldehyde to carboxylic acid. So therefore, A and B is incorrect. C. The reaction mixture is distilled immediately after mixing. So what will happen that as soon as aldehyde is formed, the mixture will be distilled immediately and aldehyde will be separated out. So further oxidation won't take place, so this is the possible option. D. The reaction mixture is heated under reflux. As we know that under reflux full oxidation takes place. So alcohol will oxidize to aldehyde and aldehyde will further oxidize to carboxylic acid. So this is also incorrect. Therefore, the only correct option is C. Question 37. Which reagents could be used under suitable conditions to oxidize alcohol to aldehyde? Number 1. Acidified potassium manganate 7. This is a strong oxidizing agent, so it can be used to oxidize primary alcohol such as propanol to 3-carbon aldehyde, which is called propanol. Number 2. Acidified potassium dichromate 6. This is also a strong oxidizing agent, so this will also convert propanol to propanol. 3 is Tollens reagent. This is a very mild oxidizing agent, so it can only oxidize aldehyde. It cannot oxidize alcohol to aldehyde. So 3 is incorrect. As only option 1 and 2 are correct, so therefore answer is B. Question 39. Which alcohols cannot be dehydrated to form alkenes? Now, dehydration of alcohols takes place in such a way that OH group is removed from one of the carbon atom and H group is removed from adjacent carbon atom. An alkene is formed along with the removal of water molecule. Now, the first option is methanol, as there is only one carbon atom, so therefore we cannot make a double bond between two carbon atoms. So this is wrong. Second is tertiary alcohol. We have CH3, 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 OH. So OH group will be removed from this carbon and hydrogen can be removed from this carbon or this carbon or this carbon, and there could be a double bond between any of these. So therefore 2 is correct. 3 is the secondary alcohol. It is CH3, CH3, and OH group is present with the second carbon atom. Now OH group will be removed from this carbon and hydrogen can be removed from this CH3 or from this CH3. So therefore there is the possibility of making a double bond or alkene. So we can say that both 2 and 3 can form alkenes. But the question says which alcohols cannot be dehydrated. So therefore the only option that is correct will be 1, and the answer is D. Question 26. Structural isomerism and stereoisomerism should be considered when answering this question. Which isomer of C6H13OH gives the greatest number of different alkenes when it is dehydrated? Now, dehydration of alcohols occurs in such a way that OH is removed from one carbon atom and hydrogen atom is removed from adjacent carbon. Similarly, OH is removed from this carbon atom and hydrogen can be removed from adjacent carbon, which could be this one or which could be this one. So 2 products are formed. Similarly, in C, we can see that OH is removed from this carbon atom and there are 3 adjacent carbon atoms that contains hydrogen. So 3 double bonds can come. In D, we can see that OH is removed from this carbon and hydrogen is removed from this adjacent carbon. So in the first one, we can see that H is removed from this carbon and OH is removed from this carbon, and this single bond will convert into double covalent bond. As we can see that this carbon that is forming double covalent bond has similar hydrogen atoms attached to it, so therefore cis-trans isomer is not possible, so only this product is obtained. So in A we have one product. Now in B we can see that this OH is removed from this carbon and hydrogen could be removed from this carbon atom, so double bond would come on this one. As we can see that this carbon is bonded to one hydrogen atom and one ethyl group. Similarly, this carbon is attached with one hydrogen atom and one ethyl group. So 2 isomers are possible for this structure, one is cis and one is trans. Now for other scenario, if OH is removed from this carbon atom and hydrogen is removed from this carbon, then double bond will come between these 2 carbon atoms. So the product could be like this: CH3, CH2, CH2, CH, and double bond will come. Then we have CH and CH3. As we can see that one hydrogen atom is present with this carbon and one propyl group is attached. Similarly, one hydrogen atom is present with this double bonded carbon and one alkyl group is attached. So cis-trans isomers are possible. As we can see that no carbon is present that is having 4 different atoms or groups attached. So no optical isomer is formed, only these 4 cis-trans isomers are formed. So in B we have 4 different products. Now looking into part C, we can see that if OH is removed from this carbon and hydrogen is removed from this carbon, then simplified product would be like this. As we can see that with this carbon we have one hydrogen and one methyl group attached, and again with second carbon we have one methyl group and one ethyl group attached. So cis-trans isomers are possible. Now with the second possibility, if OH is removed from this carbon and hydrogen is removed from this carbon atom, then the product will be like this. As we can see that with both double bonded carbon atoms, similar atoms are present. With this carbon there are 2 hydrogen atoms, while with this carbon atom there are 2 ethyl groups that are similar. So therefore cis-trans will not be possible. This will be the only product. Now with the third scenario, if OH is removed from this carbon and hydrogen is removed from this carbon atom, then the product form will be like this. As we can see that the double bond is between second and third carbon atom, and there is also a methyl group attached on the third carbon atom. And similarly in this product the double bond was between second and third carbon atom and methyl group was attached with the third carbon atom. So therefore these are actually same compounds. So we will not consider this product. So we can see total number of product is 1 cis, 1 trans and 1 this product. So total number of different products formed are 3. Now moving towards D, OH is removed from this carbon, one hydrogen is removed from this carbon, and there will be a double bond present. As we can see that with this double bonded carbon both hydrogen atoms are present, so cis-trans is not possible. This will be the only product that is possible. So in D we only have one product that is obtained. Similarly in A we only had one product. The answer is therefore B. Question 29. When this compound is formed with a little concentrated sulfuric acid, a cyclic compound is formed. What is the skeletal formula of the cyclic compound? Now we know that concentrated sulfuric acid is a dehydrating agent, so it will remove water from this compound. Let's see how cyclic compound is formed. On first carbon atom we have OH functional group. Between second and third we have alkene. And on last we have functional group present. Now what can happen is that this OH and this hydrogen can be removed in the form of water, and this carbon attaches itself to this carbon atom to form a cyclic compound. So we can draw cyclic structure like this. We have CH2, then CH double bonded with another CH, then we have carboxylic acid carbon, then oxygen, and then this carbon is attached with oxygen atom. Now starting from carboxylic acid carbon, this is first, second and third, so we can see that the double bond is present between second and third carbon. In the first one there is no carboxylic acid, ketone is present, so A is incorrect. In B we have this one as carboxylic acid, so if this is the first carbon atom then double bond should be present between second and third, so B is also incorrect. In C, we have this one as carboxylic acid carbon. So if it is 1, then the double bond is present between second and third. This is correct. And in total, we have 4 carbon atoms. So C could be the correct option. In D, we have 1 carboxylic acid and 1 ketone, which is not possible. The answer is therefore C. Question 38. Which compounds on heating with an excess of concentrated sulfuric acid produces only one product with the molecular formula C7H10? Now we know that concentrated sulfuric acid is a dehydrating agent and it will remove water in an elimination reaction of alcohols. Now water is removed in such a way that OH present with one carbon atom is removed and hydrogen from adjacent carbon atoms is also removed. Similarly, OH from this carbon atom will be removed while hydrogen from this adjacent carbon atom is removed. The products formed will be like this. If hydrogen is removed from this carbon, then double bond will come between these two carbon atoms and another double bond will come between these two carbon atoms. While in second product, if hydrogen atom is removed from this carbon atom, so the double bond will come between these two carbon atoms and one is present between these two carbon atoms. Now let's find out the position of double bond. This is first carbon, second, third, fourth and fifth. So the double bond is present between first, second and fourth, fifth carbon. In second structure, again the double bond is present between first and second carbon and fourth and fifth carbon atoms. In total, we have 7 carbon atoms in both the structures. So the formula is C7H10. So we can say that only one product is formed as the structure is similar. So therefore option 1 is correct. In option 2, OH is attached with this carbon atom, so hydrogen will be removed from adjacent carbon. Similarly, second OH is present on this carbon and hydrogen will be removed from adjacent carbon. After removal of water, double bond will come between these two carbon atoms and these two carbon atoms, and this is the only product that is possible. The structure of product is like this. There are 7 carbon atoms and 10 hydrogen atoms in total. So only one product is formed. Option 2 is also correct. In third compound, OH is attached with this carbon atom and hydrogen will be removed from adjacent carbon. Similarly, OH is attached to this carbon and hydrogen will be removed from this carbon. So we can draw the product. Either double bond will come between these two carbon atoms and these two carbons, or double bond will come between these two carbon atoms and these two carbons. Now we can find the position of double bond in this structure. The double bond is between first and second and third and fourth carbon, while in this structure the double bond is between first and second carbon and fourth and fifth carbon. So both products are different. The molecular formula of both products is C7H10. Due to different structures formed, option 3 is incorrect. The answer is therefore B. Question 26. Which reagent reacts with both of the OH groups in lactic acid? Let's draw the structure of lactic acid. We have CH3, CH, OH and C double bond O, OH. Now this is secondary alcohol group and this is carboxylic acid functional group. A. Acidified potassium dichromate. It can oxidize secondary alcohol group to ketone. B says ethanol. Ethanol can react with the carboxylic acid functional group to form ester. So it reacts with COOH to form ester. C is sodium. Sodium reacts with alcohol group and also reacts with carboxylic acid group. Sodium will react with this lactic acid and will form sodium alkoxide with OH group. And sodium salt with carboxylic acid along with the hydrogen gas. D is sodium hydroxide. So sodium hydroxide is an alkali, so it will react only with the carboxylic acid group to form salt and water. It won't react with OH group. So the only option that can react with both OH group and carboxylic acid group is sodium. So answer is C. Question 39. 3 reactions of primary alcohols are listed. Which reactions give water as one of the products? Number 1 is the reaction with ethanoic acid. Now we know that primary alcohol reacts with ethanoic acid to form ester along with the production of water molecule. So option 1 is correct. In option 2, the reaction is with concentrated HBr. We can write the reaction with primary alcohol such as methanol plus HBr. Nucleophilic substitution will take place and Br will replace OH. So the product will be CH3Br and H and OH will become H2O. So option 2 is also correct. 3. Passing the alcohol vapor over heated alumina. We can write the equation. We have ethanol, and when it is passed over heated alumina, which acts as a catalyst, alkene is formed along with the removal of water. So option 3 is also correct. As all 3 options are correct, answer is therefore A. Question number 26. Structural isomerism and stereoisomerism should be considered when answering this question. 3-methylhexane 3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula C7H14. How many isomeric compounds could be formed in this reaction? In the reactants we have 3-methylhexane 3-ol, as this ends in ol, so therefore it is an alcohol. And now we know that what happens when hot concentrated sulfuric acid is reacted with alcohol, actually water molecules is removed. So this is a dehydration reaction. Now we can see that OH is present with this carbon atom, and hydrogen will be removed from adjacent carbon, which could be this one or this one or this one, as all 3 are adjacent to this OH carbon. So when hydrogen atom from adjacent carbon is removed and OH from this carbon is removed, it will form an alkene. So 3 different alkenes can be formed. Now first possible product could be this one. Now in this product we can see that this carbon atom is attached with 2 hydrogen atoms, And as both atoms are similar, so therefore no cis trans is possible, only this product is formed. As both hydrogen atom attached with a double bonded carbon is same, so therefore cis trans isomer is not possible. In the second product, the double bond could be present between these two carbon atoms. If hydrogen atom is removed from this one and OH is removed from this carbon. Now we can see that with double bonded carbon atoms, two different groups are attached with this carbon. And again one hydrogen atom and one CH3 is attached with this carbon, so therefore cis trans isomerism is possible. So one product will be cis and second will be trans. For the third product, the double bond will come between these two carbon atoms. So again we can draw the structure. You can see that the double bonded carbon is bonded with two different groups, and this double bonded carbon is attached with one hydrogen atom and one is this group. So again cis trans is possible. No other product is possible, so therefore we have 1, 2, 3, 4, 5 possible isomers formed. The answer is therefore C. Question 27. An organic compound T undergoes the following reactions. First is that it is oxidized by a hot acidified potassium manganate 7. Second is that it reacts with sodium to give hydrogen gas. What could be compound T? A is given. Let's draw the structure. We have 4 carbon atoms and with third carbon OH is attached. This is secondary alcohol, as we can see that this carbon is directly attached with 2 other carbon atoms. Now for secondary alcohol, when it is oxidized with acidified potassium manganate, it forms ketone. And it can also react with sodium to give hydrogen, and sodium alkoxide is formed, which is like this. Now this hydrogen atom is replaced and it forms hydrogen gas. So A gives both reactions, so therefore this could be the possible option. Let's draw B. In B we can see that it is aldehyde functional group and there are 4 carbon atoms. Now aldehyde can be oxidized by hot acidified potassium manganate to form carboxylic acid. So the product will be like this. But aldehyde cannot react with sodium metal to give any product. So B is incorrect. In C we can see that again we have alcohol. Let's draw the structure. As we can see that with this carbon atoms, 3 carbon atoms are directly attached, so this is tertiary alcohol. And you should know that tertiary alcohol does not oxidize to form any product, while it can react with sodium metal to form sodium alkoxide. Along with hydrogen gas. So as only one reaction is possible, so therefore this is incorrect. Now moving towards the last one, we have ketone functional group and there are 4 carbon atoms. Now ketone cannot be further oxidized in a chemical reaction and it also does not react with sodium metal to form any product. So D is also incorrect. The correct answer is therefore A. Question number 24. Alcohol W cannot be made by reducing carboxylic acid with lithium aluminum hydride. Alcohol W gives only one product when dehydrated with concentrated sulfuric acid. What could be the identity of W? Now we know that carboxylic acid, when reduced, it converts into aldehyde, which further reduces to primary alcohol. As the question it says, alcohol W cannot be made by reducing a carboxylic acid with lithium aluminum hydride, so it means it is not a primary alcohol. Let's first find out which one of them is primary alcohol and which is not. A is butane 1-ol, so we have 4 carbon atoms and OH is attached to the first carbon atom. Second is butane 2-ol. Again we have 4 carbon atoms and OH is attached to the second carbon. In C we have 3 carbon atoms and OH is attached to the first carbon. In D we have OH attached to the second carbon. Now primary alcohol means such an alcohol in which OH group is attached to the carbon atom and this carbon atom is directly attached to 1 or 0 carbon atoms. Now we can see this carbon is attached to just 1 carbon atom, so it is primary alcohol. In the second part we can see OH is attached to this carbon atom and this carbon is directly attached with 2 other carbon atoms. So therefore it is not primary, it is secondary alcohol. Third one, we can see that the carbon atoms attached with OH is directly attached to 1 carbon atom. So again this one is primary alcohol. For D, we have this carbon atom which is attached with OH and it is further attached to 2 carbon atoms, so it is secondary alcohol. As we know that W is not primary alcohol, so we can cross out A and C. Second part of the question says that alcohol W gives only one product when dehydrated with concentrated sulfuric acid. So let's see if B and D which gives one product. So dehydration means removal of water molecule in the presence of concentrated sulfuric acid. Now for the removal of water we can see that OH is removed from 1 carbon atom and hydrogen atom is removed from adjacent carbon atom. So it could be this carbon or hydrogen atom could also be removed from this carbon. So therefore 2 different types of products are formed. Either it could be this one in which hydrogen is removed from first carbon and OH is removed from second carbon, or this one in which OH is removed from second carbon and hydrogen is removed from third carbon atom. This first compound is but-1-ene, second is but-2-ene. Now for D part we can see that OH is removed from central carbon atom and hydrogen can be removed from this adjacent carbon or from this adjacent carbon. So we can write it like this. Either the double bond is in between first and second carbon atom, or it could be between second and third carbon atom. Now let's find out the names. We have prop-1-ene, and again the double bond is present on first carbon atom, so therefore this is also prop-1-ene. So as similar product is formed, so therefore only one product is considered. So therefore correct option is D. Question number 28. The diagram shows that a carboxylic acid P may be formed from X, Y or Z. In the diagram we can see alcohol X converts into carboxylic acid. Now this is only possible when alcohol is primary alcohol. Because primary alcohol first converts into aldehyde, and aldehyde further oxidizes into carboxylic acid. If it is a secondary alcohol, then it does not convert into carboxylic acid because it will convert into ketone. In the options we can see that alcohol X should be primary, so it could be A or B. It is not C or D. And we also have to find the change in molecular mass which is greatest. Let's take an example of 1 carbon primary alcohol. So we have CH3OH. It will be converted into aldehyde, which will be HCHO, and it is converted into carboxylic acid P, which is HCOOH. So for this conversion of aldehyde into carboxylic acid, we have HCHO, 1 carbon aldehyde, and it converts into HCOOH, which is 1 carbon carboxylic acid. Now Z is a nitrile, and nitrile can also be converted into carboxylic acid upon acid hydrolysis. Let's find out which molecular mass change is the greatest one. Now the molecular mass of CH3OH is 32. HCHO is 1 plus 12 plus 1 plus 16, 30. For HCOOH we would have 46. Again for aldehyde we have 30. For carboxylic acid we have 46. For nitrile we have 27. Now we can see that the change from aldehyde to alcohol is 16. And from nitrile to alcohol is 19. So therefore greatest change is from nitrile to carboxylic acid, or Z to P. So therefore correct option is B. Question 26. Which alcohol will react with an acidified solution of potassium dichromate 6 to produce a ketone containing 6 carbon atoms? Now you should know that ketone is always formed from secondary alcohol. Let's find out the secondary alcohol. In A we have 2,2-dimethyl butane 1-ol. So in the long chain we have 4 carbon atoms as it is butane, and on first carbon we have alcohol. On second carbon atom we have 2 methyl groups. As we can see that the carbon atom attached with OH is directly attached to 1 carbon only, so therefore this is primary alcohol. So A is incorrect. Part B, we have 2-methyl pentane 3-ol. In pentane we have 5 carbon atoms. Alcohol is attached on third carbon. On second carbon we have methyl group attached. Now as we can see that the carbon attached with OH is directly attached to 2 carbon atoms, so therefore this is secondary alcohol. Rest are the number of hydrogen atoms. We have 3, 1, 1, 2 and 3 hydrogens. Now upon oxidation it will form ketone. Alcohol is converted into carbonyl carbon. So now we have CH3, CH, CH3. Carbonyl will be formed upon oxidation. Then we have CH2 and CH3. Now we can see that in total we have 1, 2, 3, 4, 5, 6 carbon atoms. So as in the question 6 carbon atoms ketone was formed, so therefore B could be the correct answer. Part C, we have 3,3-dimethyl pentane 2-ol as it is pentane, So we have 5 carbon atoms in the long chain. On second carbon we have alcohol group attached. On third carbon atom we have 2 methyl groups attached. Now this is secondary alcohol because this carbon is attached to 2 carbon atoms directly. Now this will be oxidized to ketone. Now in the product we have 7 carbon atoms, so therefore C is incorrect. For D we have 3-methyl pentane 3-ol. So we have 5 carbon atoms as it is pentane. On third carbon atom we have alcohol group attached. On third carbon atom we also have methyl group attached. Now we can see that the carbon atom bonded with OH is directly attached with 3 carbon atoms, so therefore this is tertiary alcohol. And tertiary alcohol cannot be oxidized further, so therefore D is also incorrect. Correct answer is therefore B. Question 26. Sodium reacts with 1 mole of compound Y to produce 1 mole of hydrogen gas. Which compound could be Y? Let's react these compounds with sodium. As this is alcohol, so it will form alkoxide with sodium and produce hydrogen gas. Now we can balance this equation by writing 0.5 with hydrogen. So now 0.5 moles of hydrogen gas is produced by this compound. As we want 1 mole of hydrogen, so therefore A is incorrect. Similarly, B is also alcohol. So it will form alkoxide with sodium. Again, we can balance this equation by writing 0.5 with hydrogen. So B is also incorrect as half moles of hydrogen is formed. For third reaction, we have carboxylic acid. So metal plus acid gives salt and hydrogen. Salt formed is CH3, CH2, CH2, CO2Na along with hydrogen. Again, by balancing, we can find that only half moles of hydrogen is formed. So C is also incorrect. In D, we have 2 functional groups. One is alcohol and one is carboxylic acid. So both will react with sodium. First is the reaction with alcohol to form alkoxide. So the product is CH3CHONA. And second product is with carboxylic acid. So instead of CO2H, it will be CO2Na. As one hydrogen is lost from this side, one hydrogen is lost from this side. So H2 molecule is formed. Now equation is already balanced. So we have 1 mole of hydrogen being formed from 1 mole of compound D. So therefore correct answer is D. Question 26. The reactions of 4 organic compounds are given in the table. Which compound could be propane 2-ol? We have the reagent and observations. Reagent is oxidation with acidified dichromate to give an organic product with a boiling point greater than the original compound. In second one, the reagent is ethanoic acid and few drops of sulfuric acid to give sweet smelling compound. Now propane 2-ol is the one in which we have 3 carbon atoms, and as it is alcohol, so we have OH. Now this is secondary alcohol, and secondary alcohol can be oxidized in the presence of dichromate acidified to form ketone. Now in alcohol, oxygen, which is electronegative is directly bonded to hydrogen atom, while in ketone oxygen is not directly bonded to any hydrogen atom, so therefore hydrogen bonding is absent in ketone. And due to absence of hydrogen bonding, boiling point of product should be lower than that of reactant. So we have a no. Second thing is addition of ethanoic acid. Now ethanoic acid is carboxylic acid and we have propane 2-ol as secondary alcohol. Now we know that alcohol along with carboxylic acid, they react together to form ester, and ester is a sweet smelling compound and it is a yes. Correct answer is therefore B. Thanks for watching. If this was useful, please do like, subscribe and share.